Hey, welcome! In this video, let's learn how to do data exploration. So this will be the first video in a series of videos where I will teach you things about data, so how to deal with data, and the next one will be about data cleaning. And this series is kind of going to be like a small version of my course, Hands-on Data Science, so if you're curious about that, I will leave a link in the description for you to go check that out. But without further ado, let's get started. I always get so excited when I am starting a new project because I feel like data exploration and cleaning and just generally understanding the data set is one of the most fun things that you can do. It also gives me a really good idea to, like, while I'm exploring the data set, it gives me a really good idea to how to clean it later, and also what kind of features that I can come up with when it is time for future engineering and if I, need to create some new features. So just to have just like a small advice for me, keep these two questions in your mind, like how am I going to clean it and how am I going to create new features in the back of your mind while you're doing the exploration. Don't have to be very formal, it's just some things that you need to be thinking about in the background. But let's start with the technical part. So the first and foremost, again, I feel like this is the second first and foremost thing that I said, but in the technical side of things, the first thing that you need to understand is when you find a data set in the wild and out in the open on the internet, you really can't understand a data set by itself. Of course, it could be a very simple data set, a toy data set, like a small one, very easy to understand. But most of the time, you're going to be seeing data that has some column names that you don't understand, that is kind of or it has values that you don't understand. It could have a different unit. The column values might have a different unit. The way the things are represented could be different. So likely there will be things that you will not fully understand, especially if it's in a new domain that you've never worked in before. So how we solve this is there is always going to be some explanation files for the data set that you're finding. Just want to show you some examples. Like, it might look like a PDF like this one. And it basically tells me for this specific data set that I found online, each field or column name and what they mean, what do the different values for this column mean. For example, it says it has a rate code ID. This is a data set I used for my course Hands-on Data Science. It's a New York City taxi data set. So it's basically like all the trips that happened in New York in like a whole month or something like that. So apparently this rate code, and if it's 1, it means the standard rate. If it's 2, I guess it means that they're going to JFK or Newark or, similar things, or the payment type. If you just are looking at the data, you will not be able to understand this. So it's important to see these explanation files, and you're always going to find them somewhere. So as I said, it could be in a PDF format. It could be apparently HTML format. So it'll just generate a website for you or a web page where you can see, what does this mean? What does that mean? Etc. Get some indication of like what things mean. Or it could also be just like random text files. So we can see this one, for example. So this is just some explanation, title of the database, sources, how can you use these, etc., etc. And then here, the attributes. So as I'm saying, the columns can be named a lot of things. So it could be columns, fields, attributes, features. We just need to kind of find this like table that explains what each column is. Sometimes they give you the data type. Sometimes they give you the range of the values. That's also possible. This one is like that. Or, this one is a different one that also has information about the columns. So this is the first thing that you need to find. If you are working at a company or if you're getting the data set from a different team, so you didn't find it online, let's say, in that case, you first want to understand the data set, like kind of open it on a Jupyter notebook like this, read it, and try to understand as much as you can, and write down questions about what you don't understand, and then go and find the people who are responsible for this data set and ask your questions. Like this happened to me before. And what I did is basically like just reach out to the person who sent me the data file. And then she was like, yeah, I'm sure, but someone else sends me these files. I don't really know much about them. So I was like, okay, can you give me the name of the person who sends you these files? And I talked to that person. He's like, yeah, but I just downloaded from a system, so I don't really know how it's collected. So then I'm like, okay, I'll just go to the people who created the system that collects the data. Let's say it's the engineering team. So then I go and talk to the engineering team's head, and he points me to the person who set up the system or who's responsible for the system that collects the data. And then, I ask him my question. So sometimes it takes a little bit of time to get the data, to understand the data, etc., and kind of feel comfortable with it. But this is very important because otherwise, you don't know what you're working with. The dataset that we're going to work with today is called the Street 3 census dataset. So I don't know if you're familiar with what a census is. It's basically when they go, what they used to do is go from door to door, ask people how many people live in your household, how many of them are adults, how many of them are children, how many of them are working, how much money are you making. So basically kind of like getting a lay of the land of like who lives in a certain city or a country. But they did that for trees in New York. So I might have mentioned this before, but there is a New York City open data platform where you can download a lot of different types of data sets. And this is also where I found this. I think it's really amazing. It's a really cute data set. So let me first start with reading it on my notebook, and then we start looking into it. All right, so this is a data set. It has a lot of columns. As you can see there, the 3 dots, it means that it hasn't even been able to show me all the columns, but there is actually a solution to that. If you change the settings to, how many columns that you want to show, this basically says for Pandas, set the option to maximum columns that will be shown to none. So then it will display all the columns. I don't want to set the option to show all the rows because that might be a little bit too much. So I'll change the setting and then have it show me all the columns. And yeah, I can see all the columns now. So as you can see, there are a lot of columns, and some of them are not really obvious what they are. So for example, this tree ID, okay, pretty easy. Block ID, yeah, I kind of understand what it means. Created at tree DBH, for example. I don't know what that is. So to understand what these things are, as I said, we have the file with us here. Very tiny font size, but at least we can understand what things are. So for example, 3dBH apparently is a diameter at breast height of tree. So I guess the breast height of a person. Diameter of the tree measured approximately 137 centimeters above the ground. Okay, that's cool. Diameter of the stump. I don't really know what a stump is. So when stuff like that happens, what you need to do is Google tree stump. See what it is. Tree stump. The tree has been cut, felled, and okay. Okay, that's good to know. Yeah. Whether the tree is along or offset from the curb. Tree status indicates whether the tree is alive, standing, dead, or a stump. Tree health. Oh, okay. So the tree might be a stump or not a stump. So if a tree is a stump, I'm guessing, then we only get the diameter of the stump. Otherwise, we do not have that. So this is an assumption that we're making, but we'll see if that is the case or not. Tree health indicates the user's perception of tree health. Scientific name. Common name of tree species, number of signs of stewardship observed, and that indicates the number of unique signs of stewardship observed for this tree, not recorded for stumps or dead trees. Okay, so I guess stewards are people who are taking care of the tree. That's what I understand. Good. Presence and type of tree guard, sidewalk damage immediately adjacent to the tree. Category of users who collected this tree point. All right, so this is good information. Now we know more or less what these things are. So let's look into our data set a little bit in more detail. So at first it might seem a little bit overwhelming to know where to start because, we have a lot of column names and you're like, wow, this is going to take a while to explore this data set to understand what's going on. But I think one important thing is to understand what your priorities are. So let's say generally, I just want to understand the situation in New York about trees, how much of them are healthy, how much of them are not. I just want to get a general feel of the trees in New York State, or New York City, sorry. So then I wouldn't really be caring about their location. So when that happens, then you can basically just get rid of all the columns that are giving you some information of like which state they're in, which borough they're in, which city, which street they're in, etc., longitude and latitude of the tree, etc., etc. So for now, I can actually get rid of these things, and I will make a list of all the columns that I'm interested in. And to make it easy, what I use is the columns function. It will give me all the columns, so it's easier for me to delete the ones that I'm not interested in. So all right, so this is more manageable. These are all basically if there is a problem caused by a stone on the root, if there's a problem on the root caused by a grate or other, same with the trunk, and same with branches. That's easy to understand. The Latin name of the tree, if the person who was collecting the data thought it was healthy or not, the status of the tree, if there's damage on the sidewalk right next to the tree, if there are any other problems. Okay. This is good. I can work with this. So one of the first things that I want to look at is the numerical values. So the numerical values that we only have are the diameter of the tree and diameter of the stump. But as I figured out, if this tree is a stump, so if it's cut already, then we do not have the diameter for it, which makes sense. But actually, even before that, I want to see if there are any null values. This is how I can see if there are any missing values or not. So it looks like with health, we have a bunch of missing values. So how many values do we have? 683 rows. And out of the 683, 31,000 is missing for these columns. So I want to see what it looks like when these values are missing. So I'm going to say, show me all the ones where health is a non-value. All right, so it looks like they're kind of like none for the same things. I can decide to remove these values later or not. That's kind of up to me at this point. But I'm just exploring. I'm not taking any action. So this is something that you can take note of. You can say, hey, there are a lot of missing values. I just want to get rid of these ones. Okay, this is good. So let's do describe to get a general feel of the data set. Okay, so as I said, we only have two numerical values. Well, the first one, tree ID, is actually a categorical value because it's the ID, it's not a continuous value, but it currently sees it as a numerical value, and we can see that if we do D types, yeah, most of them are strings, but the first one is an integer. So it's an integer because it's the ID of the tree, but it's actually should be a categorical value. So what I'm looking at is here the tree diameter and stump diameter. So yeah, we have these many values. The mean is 11 centimeters. Standard deviation is 8 centimeters. Okay. These are some tiny trees. And maximum is 450. That's really interesting. Is it centimeters? User collected diameter of the height of the tree. Integer, diameter of the tree measured. That was collected about living trees. Version types are more accessible than forestry specific. Let me make it close. Because measuring tapes are more accessible than forestry specific measuring tapes designed to measure diameter, users originally measured tree circumference in the field. To better match other forestry datasets, this circumference value was subsequently divided by the pi to transform it to diameter. Both the field measurement and process value were rounded to the nearest whole inch. So, okay, it's not a centimeter, it's an inch. So this is important knowledge for us. I don't know what an inch is. So 1 inch in centimeters. is 2.54. So that actually is like even more in centimeters. So if it's like 450 inches, that's like a lot of centimeters. 450 inches in centimeters even. Okay. 1,000 centimeters? It doesn't sound likely, but let's take a closer look at this actually. So what I'm going to do is I'm going to create some histograms because I want to see the distribution of these values. So let's say hist. And I already want to make the bins a little bit bigger. Yeah, it's bins. And I also want to make the figure size a little bit bigger. All right. It's interesting. So again, I'm not really looking at the tree ID. As I said, it's not really something that's important. Stump diameter is close to 0 most of the time, but then I don't know if you watch some other videos of mine, but I think I mentioned this in the hands-on data science course. If you can see this value here, that actually means that there needs to be a value here because that's how the histograms are being made. So if the maximum value was 60, the histogram range, the x-axis range would be from 0 to 60. But if it goes to all the way to 140, it means there is a value somewhere here, even if it's just 1. Same thing with the tree diameter. So I think something went wrong there. Probably when someone was trying to, put the value in, they actually want to write like 45, but I accidentally wrote like 450. So we don't know that. So I also want to see like how many values are here or how many values are here. So it looks like a logical way to cut this off is maybe like 40 here, because as you can see, there is still some values here. And also maybe like 100 inches here. Even that sounds like unreasonable to me, to be honest. But so let's see. Let me visualize that a little bit. So what I'm going to say is, give me all the trees where the tree diameter is bigger than, we're going to say like 50, to be honest. So we have 300 values. That is where the diameter is calculated or measured to be bigger than 50 inches. Interesting. So what if I visualize this? So let's say okay, this is more or less what I expected, but let me make this figure a little bit bigger. Yeah, there are some here, which I guess is expected, but like, especially after here, it's kind of like, there are 1 or 2 trees. This seems very silly to me that there will be a tree whose diameter is 450. I mean, yeah, even the circumference for 250 inches sounds like ridiculous. But yeah, this is just some information that we have right now. Good to know. Good to know. We can do the same thing with the stump diameter. All right, similar thing. I guess maybe up until this point it's acceptable. Maybe they forgot to change it to diameter. They put in the circumference, and yeah, and these values are kind of like not really correct. Could be. Yeah. All right. I mean, I guess 140 inches is not unreasonable if it's the circumference and they forgot to put it into diameter. Otherwise, it should be like a very big tree, right? If the diameter is 140 inches and that makes like a lot of centimeters, that makes like 3 meters or something. A tree with 3 meter diameter is kind of like, yeah, that would be a bit too big, I guess. I'm just trying to like work it in my head, you know, I'm trying to understand if that's like actually unreasonable or not. But yeah, when we move to the cleaning bit, I guess one thing that we would need to ask ourselves is this really unreasonable? Is this not really unreasonable? And what can we do with this data point or data points? What else do we want to look at? I want to see what are the possible options for some of these other columns. So Latin name, probably there are a lot of different Latin names, but you know, it could be interesting to see the distribution of different names. So I'm going to come here and say, okay, I guess this tree is very common, and then we have less common trees here. And one thing you can do to visualize this is to turn this counts into a data frame and then plot it, or maybe not histogram, I guess plot. Let me try a bar chart. That should work, I guess. Yeah, okay, cool. Yeah, I mean, not the most readable chart in the world, but at least it gives you an understanding of, you know, how many trees there are and which types there are. And this is kind of expected, right? You would expect some trees to be like very common, and then as you go, it's like less and less common. All right, what else can we look at? So I saw that, yeah, there are stewards, right? Some of the values for the stewards are missing. Sidewalk is missing and problem is missing. But I want to see like what are the options for stewards. So we can see here 1 or 2 or none, but what are some options? Okay, so it's either none, 1 or 2, 3 or 4, 4 or more. This is good. It looks very standardized. So, you know, if everyone had to write it down by themselves, you can see someone writing 1 or 2, someone else writing like this, someone else writing like this. So it's possible. It's good to see that it's clean. I want to see the possibilities for sidewalk. No damage or damage. Okay, good. I guess for these ones, it's either yes or no. I'm guessing this could be like a, you know, website where they fill in a form. So this looks pretty standard. I want to see the status and curb location also. Let's do it quickly. Curb block, was it? No. What was it? Curb block with the underscore. On curb or offset from the curb. Okay, cool. Doesn't seem to be need for extra correction there. All right, one last thing that I want to look into is if there is some mismatch between, you know, this tree being a stump and the health of the tree, for example. If there is any point where it says it's a stump, but it says like health is good or something like that. So I want to get all the trees where, what is the name of that column? Status is stump. Okay, then, you know, then I can say stumps. So this is like a new subset, and is all the values none for the stumps? No. Oh, so maybe these like steward, sidewalk, problems, health stuff are none for all the stumps and all the dead trees. So let me check that for the dead trees. Deads. So how much does that make? 961. So, you know, there are 17,654 stumps, it says, and 13,961 dead trees. That amounts to 31,615 total dead or stump trees. So basically, how many values did we miss? Yeah, it's more or less the same. So I guess what happened is if the tree is not alive, they didn't either bother or they didn't think it was relevant to fill in the information for the rest, for the health, Latin name, steward, sidewalk, problems, etc. And probably for these ones, to just like put 0 or something like that. Okay, so that's good to know. And also one other thing that I want to look at is how these guys are distributed. Okay, so what I wanted to see is actually how many yeses and how many nos there are for each of these columns. Of course, it's going to seem really instant to you that I achieved this, but I actually took like 20 minutes or something looking online to see, as you can see from my searches here, how I can see this information. So basically, I found that out. So what I need to do is just assign this to a data set. What should we call it? Tree problems, let's say. So this is a data set, and apparently the way to see it is like this. You just apply the value counts function to each of the series, and then you're able to see the values for all of them. So, okay, so let's see. It looks like root stone problems seem to exist a lot of the time. Yeah, no other problem exists that much. So yeah, so problems caused on the root by stones is a big problem. Yeah, this is just good information to have. You know, these are also things like when you're starting a project, these are some information, some statistics that you can give to whoever is responsible for the project, or if you just want to like kind of show that you are progressing with the problem or with the project. These are some good information to show to people. You can also turn this into like a visualization and then show it that way if these are relevant things to you. Okay, so what we did is we first looked into what are the possible features, columns that we can use. We decided that we don't really want to get into the details of where the tree is located, which borough is responsible from the tree, which street it's on. So we didn't look into that because we decided that's not important for our purposes. We looked into the columns that this data set has. We chose the relevant columns only. And on this relevant columns, we first looked into the missing values. Again, we haven't done anything with these things yet. That will be in the next video. And we looked into, you know, if these missing values happen all at the same time or not. Then we looked into the numeric values and how they're distributed in general. We looked into the distribution, the histogram, and saw that some of the values are looking a little bit suspicious. So we went deeper in those values and looked how many of them are this outrageously high. So if you saw a really even distribution here, that there are a lot of dots here and there, then you might think that, okay, maybe this is normal to have. But when you see there are only a bunch here, the kind of like outliers, then you can decide, okay, maybe this was a mistaken input by whoever was collecting the data. Same with stumps that we saw this. So, and then we looked into some names, how the distribution of different types of trees is in New York City. And some, just to make sure that all the categorical values are standard and there is no different terminology, you know, as I said, from 1 to 2, there's not like 1-2 or anything like that. So just to make sure that the values are standardized here, we looked at some of the, or most of the columns. And we actually figured out that when it's stumps or when it's a dead tree, the information on health, Latin names, whether it has a steward or not, whether it's on the sidewalk or not, etc., or if there are any problems with the tree, it has not been recorded. This is a good thing to know about the data set. And we saw that basically the distribution or how many problems, what kind of problems there are on trees. So this is a good place to stop. And from now on, what we're going to do is to start with the data cleaning.